Hello everyone, today I'll be going through the Specialist Mathematics Unit 1-2 mini quiz for week 6. So as you can kind of see here, I've got my PDF zooming in a little bit because these proof questions are not fun basically. All right, so before we get to that, we'll go to question 1, and it's to evaluate these with our calculator. So first of all, we write cot as 1 on 10 of this angle here. Then we know that this angle is the same as 3 pi on 4 because usually to, I guess, determine the base angle for something like this, right? So we know that negative 21 pi on 4, so we know that each full rotation is 2 pi, right? Which is, in this case, 8 pi on 4. So basically, we know that this thing can be written as negative 16 pi on 4 minus 5 pi on 4. And this thing here is just representing 2 full rotations, so we don't even have to worry about it. So these two are absolutely, these two are equal to each other. And negative 5 pi on 4 is the same as 3 pi on 4. And that's how I arrived at this angle here. And after evaluating that, it will give us negative 1. And second case, we write sec as 1 on cosine of negative 23 pi on 6. And that is the same as 1 on cosine of pi on 6 because by the same logic here, negative 23 pi on 6, this is equal to so 12, so negative 12 pi on 6 minus 11 pi on 6. So this is a full rotation, we don't worry about it, and negative 11 pi on 6 is the same as pi on 6, basically. And after evaluating that, we get 2 on root 3, so be careful because it's 1 on cosine. Cosine of pi on 6 is it's root 3 on 2, because it's 1 on that, so we just flip the fraction around. And the final one is 1 on sine of this, and it's the same logic of these, so I won't go over it. So negative 43 pi on 3 is the same as negative pi on 3, and after evaluating, we get negative 2 on root 3, and that's our answer here. And these are, I guess, a bit harder questions. It asks us to prove these identities, so I'll try to, I guess, zoom a little bit more to show you guys my thought process here. So my first thought process, because it's 1 plus cot on cosec, that's the same as sine of theta times 1 plus cot, right? And on this side, because there's a sec on the top, I took the sec on the bottom, so it's cosine of theta times everything here. So notice how on the top, this first part here, sine theta times bracket of 1 plus cosine, cot theta, this can be expanded to sine theta plus sine theta times cosine theta on sine theta, because these two are equal. Cot theta is equal to cosine theta on sine theta, right? And on this side here, we put tan theta into sine theta on cosine theta, and cot theta into cosine theta on sine theta. So we have something like this. Then we can do, I guess, a bit more simplifying. So sine theta plus sine theta times cosine theta divided by sine theta is just cosine theta. Here, cosine theta times sine theta divided by cosine theta is just sine theta. So it's just 1 on theta. Here we have cosine squared on sine theta. So then we keep this part similar, say the same. And here we multiply every time by sine theta. So we get sine theta sine square theta plus cosine theta square theta, which the bottom here just becomes 1, right? Therefore, this whole thing becomes sine theta plus cosine theta minus sine theta, which becomes cosine theta, which is the same as the thing we're trying to prove. Okay, so this final question here is a bit more confusing because when you see something like this, you might not know where to start. And in situations like this, I generally like to, I guess, reverse logic. So theoretically, in our writing our answer, we can't do this. But if I don't know what to, I guess, change my terms into in this case, right, I would start from the final step and work beforehand to see what I should do. And after doing that, I found out that what we should do is times the top and bottom both by 1 plus sine theta. And because here we can use this useful identity, which is a plus b and a minus b. And this will go to a squared minus b squared, right? So by using this identity, the top bit becomes cosine theta plus cosine theta sine theta, but the bottom bit just becomes 1 minus sine square theta, which is cosine squared theta. Then we can cancel out a cosine from each one of these terms, so it becomes 1 plus sine theta divided by cosine theta, which just is the same as sec theta plus tan theta, which is the thing we're trying to prove here. Yep, so hopefully that's all good. If you guys have any questions, let me know, and I'll see you next week.